This is your transformation notes, which will include 4 types of transformations. Translations, which are slides. Reflections, which can be called flips, or that's the action you take. Rotations, which is an act of turning the figure. And dilations, which is an act of proportionally in reducing, making it smaller, or enlarging, making it larger, your polygon, your figure. Now we plotted these points. A is -3, 4, B is -6, 1, C is -1, 2. You can see I've plotted them all, labeled them A, B, and C. What I want you to try to do, if you could on your worksheets, is to plot your original figure in one color and then plot your transformation in a different. It just makes a lot more sense. Now when you translate, you're actually sliding the figure. And when you go up, it's going to be positive, and when you go to the right, it's going to be positive. When you go down, it's negative, and when you go to the left, it's negative. Now, up and down is a y-axis, and side to side, right or left, is x-axis. So this says translate 3 up, so that's going to be y-axis, y plus 3, because you're going up. And then 5 right, well, that's x-axis, because right and left is x-axis, so it's x plus 5. So we have x plus 5, and then for our ordered pair for the x's, and y plus 3 for our ordered pair for the y's. We can just do this if we have a coordinate graph. So we're going to go up 3. We'll start with A, 1, 2, 3, 1, 2, 3, 4, 5. And that's going to be 2, 7. Okay, so we'll write A as 2, 7. Now let's go ahead and plug in those numbers. So we started with -3. So it was -3 plus 5. And then 4 plus 3. So -3 plus 5 is going to be 2, is going to be positive 2, and then 4 plus 3 is positive 7. So that worked out fine. Now let's do the next one. Let's go to B. 1, 2, 3. This is your y. You're changing 3. 1, 2, 3. 1, 2, 3, 4, 5 to the right. So it's -1, 4. And that was, let's go back. This is A prime. This is B prime. And let's go into the math. So we've got -3 plus, okay, so we're at our B point. So we've got, looked at the wrong ordered pair. Okay, so you have -6 right there, plus 5, which is -1. And then you have 1 plus 3, which is 4 right there. Okay, the last one is going to be our C. And so we go up 3, 1, 2, 3, and over 1, 2, 3, 4, 5 to the right. And that's going to be C prime. And we are going to connect these in just a minute so you can see they're the same figure. But let's first do this. So that's 4, 5. So we would have had -1 plus 5, that's 4. And then we have 2 plus 3, so y plus 3, 2 plus 3, and that's 5. So 4, 5 works. Now you connect the points. Basically you have the same shape, same figure, congruent figure in this case. All the figures will always be congruent until you get to dilations, and then they'll be similar. So you have a congruent figure, but it's just shifted. Okay, it's no longer in the same position. All right, let's go ahead and go over here. You try this one. It says it's still the same ordered pairs, but I want you to translate 4 down and 2 to the right. Go ahead and show all the work, and then as soon as you finish, turn the recording back on. All right, you were to translate 4 down. Now up and down is your y coordinate, so it's y minus 4, and 2 right. Well, that's whenever you go right or left, it's your x coordinate. If you go to the right, it's going to be positive. If you go to the left, it'll be negative. And so we had -3, 4, -6, 1, -1, 2. They are all plotted in red, same as the one before. And we actually could just go from the graph and go down 4 and then over 2. But if we actually plug in the numbers, you can see you get -1, 0, because -3 was the ordered pair, plus 2 is -1, and then 4 was the y coordinate. 4 minus 4 is 0. On the point B, -6 plus 2 is -4. There it is right there. And then 1 minus 4 is -3. And then finally -1, 2. -1 plus 2 is 1 right there. and 2 minus 4 is negative 2. So you can actually just go like this. Say we did B, down 1, 2, 3, 4, but then over 1, 2, plot your point. So it's all quite simple. You can do it mathematically, or you can do it right on the graph. We're now moving to transformation notes for reflections. We're going to reflect over both axes. Okay, so in these transformation notes, we've used the same ordered pair for A, B, and C. You can see it up here, right there. We're going to do reflections, or sometimes referred to as a flip. That's the action that happens. And you are going to reflect over first the x-axis. So we're going to reflect over the x-axis. This is the x-axis, which means if you flip it, it's got to come down into quadrant 3. It's in quadrant 2 now, so it's going to be in quadrant 3. So you need to make that observation that will reflect into quadrant 3. And that helps you know if your pattern for your points is correct. Then we're going to, on the next one, reflect over the y-axis. So this will be the y-axis. Now if you're in quadrant 2, that means you're going to be reflecting or flipping this figure over into quadrant 1. Now this will be like a mirror image is what it'll look like. It's like when you look in the mirror and the letters on your shirts are reversed. This is what it's going to be. Okay, now I'm going to do the y-axis, then you're going to try the x-axis. But let's just keep in mind, reflecting over the x-axis in this case will give us quadrant 3 points. Reflecting over the y-axis in this case is going to put us into quadrant 1. And that'll help us know if we've got things right. Okay, from A to get to the x-axis, it's 1, 2, 3, 4. So it's going to be 1, 2, 3, 4 the other way. Plot it. That's going to be our A prime. For B, it's 1 from the x-axis, so we going the other way, so that's going to be B prime. And then for C, it's 1, 2 from the x-axis, so we go 1, 2 on the other side, and that's going to be C prime. And so you have this flipped triangle. It's a mirror image. And A prime is going to be negative 3, negative 4. B prime is going to be negative 6, negative 1. C prime is going to be negative 1, negative 2. And what I'm hoping you noticed is that the numbers stayed the same, so that's 3 and a 4 and a 6 and a 1 and a 1 and a 2. So the numbers stayed the same. And there's two other ways that you can look at what happened to the signs. If you know you're going into quadrant 3, so the quadrant 3, not every time, you don't always reflect in quadrant 3, but the quadrant 3 pattern is negative, negative. Well, then you know that your ordered pairs have to be negative, negative. To me, that's the easiest way. Or you can go ahead and say, okay, when you reflect over the x-axis, the x-coordinates will stay the same sign, but the y-coordinates will change to a different sign. It's just however you want to think about it. So the y, when you reflect over the x-axis, the y-coordinate becomes an opposite. You can think of it either way. So this is kind of an or type way of doing it. Okay, so you try or the second reflection. This time you're reflecting over the y-axis. As soon as you're finished, turn the recording on and see how you did. Okay, when you reflect over the y-axis, it went into quadrant 1. It's the mirror image of it. And A prime is 3, 4, B prime is 6, 1, C prime is 1, 2. If you haven't already noticed, the numbers are the same as the initial ordered pairs. But now you're in quadrant 1. And quadrant 1 is always positive, positive. So you have all positive values. That to me is the easier way. But you could also think of it, if I'm reflecting over the y-axis, then my x-coordinate is going to become its opposite. So you can see that all the x-coordinates, negative 3, negative 6, negative 1, became their opposite value of 3, 6, 1. However you want to think about it is what you should do. Due to, I think we're going to end up with some space constraints, I'm going to go ahead and put this transformation notes on 2 separate recordings. So this will be recording 1 with translations and reflections. The second recording will have rotations and dilations. So go ahead and look at the appropriate one if you're having trouble.